Hello everyone, my name is Solar and this is Solar 3D Studio channel. This lecture is about the deformation of a 3D shell plate, which is actually an static analysis in Abaqus 2024. Okay, so here is the final result of the simulation. As you can see, let's just start the simulation, but before starting the simulation you can see the manuscript and the notes of this simulation on the left side of the picture here, and I highly recommend you to pause the video, write down the notes and follow my instruction on how to do this simulation. Okay, let's just move forward. Okay, as always we need to create the model database, which is a standard explicit model. Okay, let's just create a 3D shell plate through parts module. Okay, let's just change the name 3D shell. No, not that. Modeling space will be 3D, the type will be deformable, the shape is going to be shell, and the type is going to be planar. We also stick with the approximate size as a default. Okay. Oh, sorry. Let's just change it to shell. Okay. Okay. I'm going to do this. This side is 75 and this is going to be 30. Okay. Great. Done. Okay, our shell is created. We are done in our part module, so let's just move to property. Create the property. The elastic modulus is 200E3 and the Poisson ratio is 0.3. Just change the name to steel. And okay, let's just create this section, which is section steel. It's going to be shell homogeneous. Okay, the shell thickness is 1 based on the problem. Okay, everything is cool here. Just click on OK and assign the section to our plate. Okay, great. Go to assembly, just import it as dependent. Okay, great. Let's move to the step, which is in static general with default items. Okay, go to load module. We have a BC1, it is in caster on this edge. Great. And let's move to the mesh because we need some nodes here for the second boundary condition. Okay, it's going to be 1. I think 1 is good. Okay, and oops, sorry, just assign the mesh. Great. And go to tools, set. Let's just create a set for our load nodal set, and let's just choose this node. Okay, I prefer this node. Okay, let's just go back to the boundary conditions. We are going to apply a concentrated force to the shell 1 set. Okay, so we're going to apply through the Z direction. Let's just show you why I'm talking about this like that. Okay, as you can see, we are going to apply a force to this side of the plate towards the Z-axis. So the CF1 is 0, CF2 is 0, 2, and the CF3 is minus 15. Okay, we're also again going to use amplitude, and again, if you don't know about amplitude, please just follow the link in the caption to the video which I have created about why and how to choose the proper amplitude for each type of simulations you are going to do. But in this case, I'm going to use equally spaced amplitude with 0 and 0 and 1 and 1. Okay, great. Everything is cool, and I think everything is okay. Let's just create the job. Let's create a shell and just wait to see the results at the end of the simulation. Great. Okay, here is the final result of the simulation. Let's just see what just happened. Okay, this is the encaster boundary condition, and here is the applying force direction. As you can see, the plate just deformed towards the applying force, and I hope you understand this beginner tutorial and expand it to more advanced type of simulations. Please share your thoughts and questions on the comments below, and also you can use my LinkedIn page if you have specific questions or problems which you need to receive answers quickly. Okay, as always, do not forget to subscribe to my channel and turn on your notifications to receive weekly useful Abaqus, Procast, and metamaterial tutorials. Thank you so much. Have a nice day.